guys, I'd gotten quite a few emails about the Chapter 6 project. Remember, you can work with a partner. I've heard from some of you that you are, which is awesome. But there were mostly questions about Chapter 1, so I thought I'd figure out a way to make you a video and help you guys get started. So Chapter 6 project is right at the end of Chapter 6. It's all about talking about two different types of paradoxes. And this is the first paradox we're examining. It's a paradox that under certain circumstances, that's a key word, we don't know what circumstances, but under certain circumstances, you have your best chances of winning a tennis tournament if you play most of your games against the best possible opponent. So that's the paradox that we're given. Then we have another situation, right? Our situation is we have three sisters, Alice, Betty, and Carol, very creative names, and they play tennis. And Betty is the best of three sisters, and Carol plays at the same level as Alice. So because Carol and Alice are the same, it makes sense that Alice defeats Carol 50% of the time, and Alice defeats Betty 40% of the time, right? Betty's the best. Alice's mother offers to give her $100, which is just weird, if she can win 2 consecutive games when playing 3 alternating games between her sisters. So meaning she can play Betty, Carol, Betty, or Carol, Betty, Carol. And the question we are asked is, first, let's make a guess, which is the best sequence for Alice to choose, okay? You should probably do this before you start your calculations. If your guess is wrong, awesome. If it's right, equally as awesome. Make a guess and tell me why. Should she play Carol, Betty, Carol, right? Because she'll play the weaker opponent the most. Or Betty, Carol, Betty, because then if she won the $100, she'd feel like a lot better about it. I don't know. So that's something to keep in mind. I'm on my porch. That was thunder. Sorry, guys. Okay, so the next thing I want you to do is calculate the probability of Alice getting $100 if she chooses the sequence Carol, Betty, Carol. And remember, she has to win 2 consecutive games. So my recommendation would be to set this up using a tree diagram, okay? First thing she does is play Carol. And she either wins or she loses. How often does she win against Carol? 0.5. How often does she lose against Carol? 0.5. Next, she's going to play against Betty. Remember, when we're making a tree diagram, we fill in the probabilities. How much does she win against Betty? 0.4, which means she loses 0.6, right? Whether you win or you lose, that's the only 2 options, and it has to add up to 1. Next, she's going to play against Carol, okay? She's either going to win or lose, which is 0.5 or 0.5. Win or lose, which is 0.5 or 0.5. Win or lose, 0.5, 0.5. You might want to make yours bigger. Win or lose, 0.5, 0.5. Okay, so here's what I care about. I care about, let's use blue. I care about when she wins 2 consecutive times. So let's take a look. So if she beats Carol, she'll win, and then she could win again or win again. Here she beats her 2 consecutive times. But she would also beat her 2 consecutive times if she followed this tree. She would also win 2 consecutive times if she lost, but then won 2 games. So this tree. So what you need to do is calculate the probability of each of these 3 branches and add them up, and that would be the probability. In this case, she would win 2 in a row. The next thing you need to do is do the same thing, but this time she's playing Betty, Carol, and then Betty. So you need to see what's the probability of whether she wins or loses. Wins or loses. These are some sloppy W's, I'm sorry. Wins or loses, right? Fill in the blanks with the given probabilities, whether she's playing Betty, Carol, or Betty. And figure out the probability of her getting that $100, so winning 2 games in a row, if she chooses this sequence. The next thing you need to do is, once you've calculated the probability of her winning $100 for each of these sets, which sequence should she choose? You will find that out from your calculations. So this is something you have to calculate. And then last but not least, I want you to explain to someone who doesn't know what probability is. Maybe try and explain it to someone in the PEP who's not in our class, maybe one of your other friends who's not in the program, but practice, right? Explaining why, if depending on what you choose, why you chose that, right? Even if it seems like you shouldn't have chosen that. Hint, hint, wink, wink, okay? So that hopefully answers your questions you had on the first part of the Chapter 6 project. Remember, if you have any more questions, to reach out to me. I do love hearing from you guys. Enjoy your night.